Last time, we learned about the chain rule, and we did some exercises where you identified which are inner functions and which are outer functions. Those are preliminaries so that we can now begin our treatment of the process of differentiation when we have compositions of functions. In this video, we're going to learn how to do differentiation using the chain rule. Let's get started. You will see on your screens now the chain rule again written. The derivative of f circle g of x is the derivative of f with respect to g of x times the derivative of g of x. How do we do that when we have examples now? All right. So here we said first, for example, in number 1, you have, sir, the inner function is 2x cubed and the outer function is something to the fifth, right? So to apply the chain rule, this is how we do it. We differentiate the outer function, u to the fifth. We do the outer first. So, sir, that is the power rule. F prime x is equal to, now the outer function is u to the fifth. So, sir, by the power rule, that is 5. Now, u, we know what u is. U is 2x cubed. So 2x cubed to the fourth. All right, so you just applied the power rule. And then, according to the chain rule, you have to differentiate also the inner function. So the inner function is 2x cubed, so the derivative of that is 2 times 3, 6x to the 2, or 6x squared. Again, using the power rule. Simplifying this will give you 5 times 2 to the 4th x to the 12th times 6x squared. Or further, this is 5 times 16, that's 80, x12 times 6x squared. Or finally, that should be 480x to the 14th. That's according to the chain rule, right? So you see, we derive first the outer function, okay, using, again, let me just highlight that. Okay. This is the derivative of the outer function, okay? And then after the outer function, so outer first and going in. So that's how we remember the chain rule. Outer first, going in. There is actually a way to know if this is correct. We can do this problem not by the chain rule, but we can do this by first expanding 2x cubed to the fifth and then differentiating. So that means that we can take f, so this is another tack. We could have expanded f of x to 2 to the fifth x to the 15th. You will have your loss of exponents to help you with that. Or this is 32x to the 15th. Now that you have this simpler function that is not a composition of functions, you can directly apply the power rule. We have f prime x is equal to, that's 32 times 15 raised to times x raised to 15 minus 1, which is 14. So what is 32 times 15? That's 480 x to the 14th. You will see that in both approaches, whether you did the chain rule or whether you expand first before derive, then derive. So here you are seeing two approaches to the same problem. You get the same answer. whether you use the chain rule or you do an expansion first and then the derivation that follows after. It's good if the function that you're dealing with can be expanded first before deriving, but not all functions can be done that way, and therefore you would have to need to use the chain rule. All right, let's take a look at another example. Let's have number 2. Like before, we said first we must identify what's the inner function and what's the outer function. If you could recall, the inner function in this problem is 5 minus 2x. The outer function is square root of something. That something happens to be 5 minus 2x in this particular example. So how do we apply the chain rule? Right. First, we derive the outer function. Okay, so using the chain rule, you will have, what's the derivative of the square root of something? Sir, first I can rewrite that as u to the 1/2. Okay, square root of u is u to the 1/2. And therefore, the derivative, sir, is, or sorry, the derivative of square root of u is 1/2 u to the negative 1/2. Of course, because 1/2 minus 1 is negative 1/2. So that means that, remember, we're still dealing with the outer function. So f prime x is 1/2 something 2x raised to the negative 1/2. Okay. This is yet the derivative of the outer function. The derivative of the outer function. Now, according to the chain rule, you have to multiply the inner, rather the derivative of the inner function. So, sir, what is the derivative of 5 minus 2x? So, what is the derivative of 5 minus 2x, sir? That's 0 minus, sir, that's negative 2. So we multiply negative 2. Or rather, f prime x now will be negative 5 minus 2x raised to negative 1/2. Or this is negative 1 all over the square root of 5 minus 2x. Or if we do the rationalization, this must be negative square root of 5 minus 2x all over 5 minus 2x. And this is good. Of course, we can stop here. Okay, so I'm telling you, you can either stop here or you can go further, expand up to the rationalized final answer. In the examination or in your formative assessments, I could accept even until here. So just so you don't have to, because the rest is algebra. From this step down, that's just algebra, no longer calculus. Okay. Now on to number 3. So first, again, we need to identify what is the inner function and what is the outer function. Sir, the inner function is x cubed minus x. The outer function, meanwhile, is something squared. Correct. Now, using the chain rule, this is what's going to happen. You will have, sir, first I derive u squared, so that's going to be 2 times something. That something is x cubed minus x. We do know that. Raised to 2 minus 1, which is 1, but then we no longer need to write that. Okay, so now after the outer function has been derived, the inner function, the derivative of the inner function is, sir, that's 3x squared minus 1. All right, so you have f prime x is equal to this. Okay, now to simplify, this is going to become 2 times 3x to the 5th minus x cubed minus 3x cubed plus x or this is 6x to the fifth minus 8x cubed plus 2x. So there you have it, using the chain rule. All right. Again, of course, the calculus stops here, and everything that follows is just algebra. So the calculus stops, the chain rule stops here. You've already done the chain rule on this part, and everything else is just plain algebra. Now, you might have a question, sir, can we do the differentiation process without using the chain rule? Well, apparently with this example, you could. Okay. How? How do I do that, sir? Well, first you expand f of x, make it x to the 6 minus 2x to the fourth plus x squared. Okay, if you did an expansion of x cubed minus x squared, you will get this. Before you get the derivative, because this one you can use already the old differentiation rules that you know, the sum of a function rule, the difference of functions rule, and the power rule. So correctly, this is 6x to the fifth minus 8x cubed plus 2x. You will see that whether we did, okay, let me just write here, expand first before deriving. Okay, so whether you use chain rule or the expansion first before deriving, you will get the same answer, which tells you that probably you are correct. Okay, probably you are correct. They're equal. Okay, so that is all for now. In the next video, we are going to learn how to apply the chain rule when we have transcendental functions. Bye-bye. See you next time.